Hello. Today I'll take you through Assembly 3 from Schoology. So this is an assembly that is in metric, MMGS. So you want to make sure that you change your units to metric. We will be using millimeters. You have 5 different parts. You have the pin, super easy. You have this axle that the wheel spins on. And then you have the base, which is on a separate file in Schoology. And then you have the kind of the axle holder, which is this angled piece right here. You can see this here. And you can use that same piece twice, so you do not need to make it again to make the other side. That's just a mirrored component. And then you have the wheel on the inside. This tutorial will take you through how to create the wheel, which is a cylindrical object. It's round. It's got some angles to it. I'm going to zoom in here so we can look at our dimensions very closely. All throughout this page you will find dimensions for various parts. Okay. Notice that the coordinate system, the origin is in the middle of the base. So when you create the base, you may want to start with the origin in the very center of this line that runs back and forth. So we're going to use this view here, which is called a section view. That's why you see the slanted lines there. A section view is a view that cuts the object, or in this case the assembly, in half, so we can see interior components, interior features. So everywhere you see the slanted lines, those are called section lines, is where the imaginary cut actually cut through material. So this area right here, which is white, did not cut through material. And in this case, it took out the axle, so we can see how the axle would fit into that area right there. So we're going to use both these views to gain dimensions for our wheel. So in SOLIDWORKS, I'm going to start in my right plane, because what I'm going to draw, go ahead and zoom in here a little bit more, I am going to draw this shape right here. Okay. The wheel itself has a hole in the middle where the axle will fit. And so I'm going to place, for the wheel, I'm going to place my origin right here, which is at the center of this symmetric object. So the wheel is symmetric top to bottom and side to side. We're going to use a new feature today called Revolved Boss Base, which is great for cylindrical objects. So what I'm going to do is I'm going to draw this kind of eye looking shape with this angle here. I'm going to utilize dynamic mirror to draw this. So like I said, I'm going to use my right plane. And the first thing I'm going to do is I'm going to draw a couple center lines, and I'm going to show you I'm going to do a midpoint line. So a midpoint line allows you to create a line from the midpoint and then just drag out. I will then select these lines and choose for construction to create construction lines or center lines, either one. And so now, looking at this shape, I want to draw this right here, which is just a series of lines, and then I'll dimension them with this angle up here at the top as well. So I'm going to use dynamic mirror because this side is the same as this side over here. So I will go up to here and go dynamic mirror entities, and I'm going to choose my vertical center line. Notice that my two little lines are here on the center line, which tells me I am in dynamic mirror mode. So what I can do is I can start drawing. Now what I want to look at is I do not want to start drawing from the origin. I want to draw directly above the origin. Remember, this is space. This is going to be a hole in our wheel. So we're going to create that hole by not drawing from the origin, but picking a point above it on that center line. And then when I get to the top, I'm going to zoom in here for you, add a little angle here, like so. So it gives me a closed contour. You can see by the gray on the inside. And now what I will do is I'll start dimensioning. Now, this is a cylindrical object, right? It's round, it's a circle with a lot of different dimensions. So we can see the depth is 50. So I could start there. This is going to be 50 millimeters. And from there to there is 40. Whoops, I might have typed that in wrong. 40. I have an 80-degree dimension right here, so between these two lines is 80 degrees. Let's see, what else can we get off of this drawing here? So maybe I can't find enough there, so I can go to my isometric view, and I can see here that the outside, the biggest part of the wheel, has a diameter of 100 millimeters. So when you're doing a revolve and you have center lines and you're talking about diameters, right? So this is going to be revolved around this axis, which is this center line. So I need to tell it that from here to here is half of that diameter. Now notice I clicked on this line and the center line. Well, if I drag my mouse below that center line, it gives me a diameter option. So I know the diameter is 100 units, 100 millimeters. And I know the inside one here is 90. So I could choose this and the center line, and I could tell it is 90. Now, as I'm doing this, things are starting to get a little crazy here, so I might extend my center line. I might take my V and drag it. Oops, I added a relation there, so add a V, just kind of move things around a little bit just to make them look a little better. And so now the interior here has a diameter of 35. And what that is that that's from this point to the center line, 35. And then lastly is the hole. Well, the hole is going to be told, that's going to tell me on this view here. So we have 20. So this 20 is, follow the lines to that interior part of the hole. Okay, so notice that is 20 and the actual biggest diameter of the axle is 19.9. So you have 0.1 millimeter clearance. Things don't fit together perfectly. There has to be a little bit of space or else it will not go together. So that 1.1 millimeter distance actually creates that tolerance. So I'm going to use 20 from here to the center line. All right, so things are starting to turn black, be fully defined. No, I'm not going to sing the song right now to you. So now I just need to figure out, okay, what is that? So that is, oh, that's 10 right there. So from here to here, that's 10 millimeters. And then lastly, I need to define my V, and I need to add a relation that says that this point and this point are horizontal from each other. And so that looks pretty good. So my sketch now is fully defined. So I use dynamic mirror to be able to create that, and then I use my diameter dimensions, which is super easy because all you have to do is click on the center line and the line you want to, and you can create the diameter. And now I will use the Revolved Boss Base tool, which is on your features toolbar. It's the second icon, Revolved Boss Base. So whenever we are using the Revolved Boss Base, we have to revolve around the axis. So it's asking us for what is the axis of revolution. And when we have a sketch, it's usually a center line. I could use this line, but this is the center of my revolution. So I want to choose this line. Notice there's two center lines. So I want to make sure I choose the correct one. And it gives us a preview. It's going to take that profile sketch and it's going to extrude it around that axis in a circular fashion. 365 degrees, 360 degrees. And there, unless we have to add anything else, our wheel has been completed.